This is a continuation of the Day 6 notes on confidence intervals. We've begun to talk about the differences between matched pairs t-intervals and two-sample t-intervals. We're on page 2 of your notes worksheet, and we want to talk about degrees of freedom, first of all starting with the matched pairs t-interval. When you're working with a one-sample t-interval or a matched pairs t-interval, the degrees of freedom are equal to n minus 1, which we've run into several times, where n is the number of items in your list. For a two-sample problem, it's a little bit trickier. To find the degrees of freedom for a two-sample t-interval, there's a formula in your book on page 659 to calculate this. And the formula for degrees of freedom for a two-sample t-statistic involves taking standard deviations, sample sizes, and crunching out this awful-looking fraction. So this is not a formula you're given on your formula sheet, so you'd have to choose to memorize this formula. Because it's a little bit tricky, let me suggest a couple other ways of finding the degrees of freedom. In my calculator, I've entered some numbers into two different lists. You'll notice that there's more numbers in one of the lists than the other, but I've got two lists of data here. If you press the stat key for statistics, if you hit enter, you can access the list. We've used calc before, which is used for one-var stats and linear regression. Today we're going to go over to where it says tests. And if you scroll down this list, you'll actually see something that says z-interval, like the one-sample z-interval, t-interval, like the one-sample t-interval, and two-sample t-interval, which is what we're working with right now. And what's kind of cool is if you have two lists of data, you can select this option on your calculator by going to stat tests, two-samp t-int, two-sample t-interval. If you hit enter and you have data in lists, you can put your list in L1 and L2, set the frequency levels to 1 and 1. C level stands for confidence level. Usually for the default, we'll select no for pooled. And then if you go down to the bottom where it says calculate and hit enter, your calculator will actually tell you the final numbers that make up your two-sample t-interval. And underneath that, they give you the degrees of freedom. So in this problem, the degrees of freedom would be this decimal number. Yes, you can have decimal degrees of freedom, 6.08. Your calculator will also tell you values like x bar 1, x bar 2, the two standard deviations, and the two sample sizes as well. So if you're finding degrees of freedom for a two-sample t-interval, this is the method I would suggest because it's a lot quicker, a lot easier, and you don't have to memorize a formula. Or your third option, in a pinch, what you can use is the smaller of the first sample size minus 1 or the second sample size minus 1. This isn't the best option. The other two formulas will give you the exact values, but in a pinch, using the smaller of whatever one of the small sample sizes is minus 1 will at least give you an answer that's in the ballpark. I prefer you not use that, but if you forget the formula and you forget how to do two-sample t-interval on your calculator, you can use that. Interpreting results. For the matched pairs t-test, we said that we are blank % confident that, this should say mu diff, the mean difference or increase in whatever is between your two numbers. For a two-sample t-interval, it's a little different. We're going to say we are blank % confident that the difference in mean, whatever it is, mean heights, mean weights, mean test scores, is between blank and blank. So for the matched pairs t-test, we say the mean difference in something, and for the two-sample t-interval, we say the difference in mean something. Mean difference, difference in means. So let's review the 4 different confidence interval formulas we've looked at so far. The formula for one sample z-interval for means is x bar plus or minus z star times sigma over the square root of n. The formula for a one sample t-interval for means is x bar plus or minus t star times s over the square root of n. The formula for a matched pairs t-interval for mean differences is x bar diff plus or minus t star times s diff over the square root of n. And the formula for a two-sample t-interval for difference of means is again x bar 1 minus x bar 2 plus or minus t star times s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. We're going to be focusing today on the two-sample t-interval for difference of means, so we're going to be looking at the problem on the next page. So let's take a look at this one.